These notes are on solving one variable quadratic inequalities. So I'm looking at this problem and it looks very familiar, looks very similar to the solving quadratics. The one catch being that I have this inequality right here. It doesn't say equals 4x plus 1, it says less than or equal to. So for a moment, I am going to do a little side work, and I'm going to, so I'll write this as side work. And in my side work, I'm going to rewrite this so that it's equal to 4x plus 1. I know that in order to solve a quadratic, I need to get everything over to one side, have the quadratic equaling 0. So I have x squared minus 4x minus 5 equals 0. First line of defense when I'm solving quadratics is factoring. This does indeed factor, so I have x minus 5 times x plus 1 equals 0. I have x minus 5 equals 0, or x plus 1 equals 0. So x equals 5, or x equals negative 1. Now, very often when I'm doing this kind of work, I could graph it. Because I only have one variable here throughout the entire problem, my graph is going to be on a number line. So I have 0, negative 1, positive 5. And the way I graph these when these are inequalities is to simply fill in 2 dots, 2 points. Well, when I go back and look at the original problem, that less than or equal to, so what I've got happening there is that these two solutions break up my number line into 3 regions. So let's go back to our original. But let's stop at this point right here. So we'll have x minus 5 times x plus 1 is less than or equal to 0. So I know from my work above that I have negative 1 and 5 as my boundaries. So the question really becomes, and it's less than or equal to, so it is closed circle. So the question becomes, well, where do I shade? That's what inequality means, is that it's in a zone, it's in a region, it's not an exact value. It's not like it's only negative 1. It could be negative 2 and lower or whatever. So in order to determine which parts of this I want to shade, I am going to do a little quick test. And my test is this. I am going to put into each of these regions my x minus 5 and my x plus 1. X minus 5, x plus 1, x minus 5, x plus 1. And I'm going to pick a number in each of these regions. So I'll pick negative 5 for this most left-hand region. So I've got negative 5 minus 5 and negative 5 plus 1. And I could simplify this, or I could recognize that I really want to know what kind of number this is. Is it positive? Is it negative? Does it equal 0? So I'm going to look at this and I'm going to say, well, that's a negative number times a negative number. So I have a positive number in this region. For my middle region, I'll pick 0. It's actually the easiest here. So I've got negative 5 times 1. So I've got a negative times a positive. So I have a negative number in this region. For the most right-hand region, I'm going to pick 6. So I have 6 minus 5 times 6 plus 1. That's a positive times a positive. So this region has a positive number. Now this is when I go back and I look at my inequality. My inequality here says that I want numbers that are less than or equal to 0. So numbers that are smaller than 0 are the negatives. And in which of these regions do I have negative numbers? Smack dab in the middle. Now, a minute ago I said we wanted to know whether or not the solutions that we're plugging in result in a positive number, a negative number, or 0. Anyone see where the 0 is? Where are the solutions where if I plug them in I'd get exactly 0? That's right, they are indeed where the boundaries are, because that's the work I did above. the boundaries are where the value of x makes the equation equal 0. So my last step here is I'm going to write this answer as an inequality. So I have -1 less than or equal to x less than or equal to 5. This is set notation, and to be, so we have x such that, and use my brackets, or I could also write this as interval notation -1